Hello everyone, my name is Jason Gregerson, and this video is going to be Introduction to LaTeX. We're going to start this video by first describing what is the software LaTeX. After that, we're going to go into the different parts of a LaTeX file. And after that, we're going to start by creating some documents and actually typesetting some mathematics. And finally, we're going to introduce how to compile your file and actually create a PDF document, and how to get your own LaTeX system on your computer. All right, so we'll start off with what is LaTeX. Well, essentially, it's a markup language for technical typesetting. So LaTeX will allow us to type some content into a regular plain text file and then insert some commands that will help us typeset and make these into really professional grade documents. Now it's preferable to what you might have been using before if you were using something like Microsoft Word to create your documents. There's a lot of advantages to using LaTeX. The first is that it allows us to think about the logical structure of the document without actually worrying about doing the typesetting ourselves. We don't have to worry about getting the numbers right in the list. We can just tell LaTeX that we want to have a list structure, and then we'll keep track of those details. The other big advantage is the quality of the final product. The documents just look more professional when they're created in LaTeX. So let's see how we get started. So once again, we can start by just opening up a regular text document. So here I'm running Windows, and so I've just opened up Notepad. I'm going to start creating my first LaTeX source file. So every LaTeX file has the following form. It's going to start off what's called a preamble. And that's going to start off by defining what kind of document we'd like to create. And in my case, I'm going to start off with a document class, and I'm going to call it an article. So the document class defines what type of document we're going to make. I've chosen to use article here, but you could also use report, or book, or exam. And for each one of those, this is where we're telling LaTeX how we want our document formatted. So there's other things we can put in the preamble. We could, for instance, add some definition, load some packages, and do some other things. We're going to leave that blank for now. So after I complete the preamble, I'm going to start my document by typing begin document. Then I'll type in the body of my document. In this case, I'm just going to say hello world, and then I'm going to end my document. And this would be a LaTeX file. Now what I'm going to do is I'm going to save this. I'm going to call it my first LaTeX, and I put the extension TEX on the end. So now I can see in my folder that I've created this document. So these are the instructions for how to actually typeset this thing. But now what I need to do is compile it to actually create the document. So I've already installed LaTeX on my computer. So one way I can compile this document is to compile it from the terminal. So in the terminal, I simply go to the folder. So in my case, I will change my directory to Dropbox desktop LaTeX lessons. Once I'm in this directory, I will use dir to observe that, yep, there it is, my first LaTeX text file. And then use the command pdf LaTeX, and that's going to run on my file first LaTeX text. When I run that command, it's going to compile my document. And so we can see that some other files were generated here, a log and an auxiliary file, and also the PDF that I'm looking for. So if I open up this PDF, sure enough, there's my typeset hello world. All right, so far we've seen that we can create LaTeX source files in a regular text editor, and we can compile them using commands from the command prompt. And this doesn't only work in Windows, it also works in Linux, that same command pdf LaTeX. So we can definitely create our documents that way. And this is very similar to how one might compile C code. They would write out the code in a text file, and they would use something else to compile it. But when you write C code, you can also use an IDE, which is a software that runs on top of everything that gives you some extra tools and resources when you're compiling your C code. And the same thing is true for LaTeX. So in other words, if I have closed out my document and my terminal, and I will also close this file, I'm back in my folder. I have already installed some extra software, so I have what's called Technicenter, and I will open this up. And this is just my preference for um, my software on top of LaTeX. There are many other versions of the software. One that's popular for Linux systems is called Kile, K-I-L-E, but they all have many of the same features. So here's my document. It will show the build process down here below, some other windows. If I want to build a document, I can go up here to the menu and say Build. And I could just build it and create those additional documents, or I can build in View, and it will construct all the files and also generate a PDF right away, so I can see my work right away. And when I did that, you can also see that on the specific software, I have a shortcut, Control, Shift, and F5. So now I can just add new text and Control, Shift, F5, and it will recompile and generate that PDF view. There it is, add my new text. Now, a couple things to note right away as we're doing this. I'm going to hello world here, and I'm going to delete that text. Hit a couple lines of enter. Hello, back to you. And I'm going to run that. And one thing you'll notice here is that I have hello world and hello back to you, but when I type this out, I put a double space in between those lines. And when it compiled, there was no double space. And so it's really important to remind yourself that this is not a what you see is what you get typesetting environment. This is something where I'm going to type in the commands that are going to make it look the way I want it to look. So what other things can we do inside of this document? Well, one thing that I often want to do as I'm creating quizzes or exams is I want to keep things that are numbered. So to number things in LaTeX, I'm going to go into the enumerate environment. So I'm going to begin my enumerate environment. Once I'm in this environment, if I want to have things that are numbered, I simply label them as items. So this is my first item, item 2. This is my second item. And then whenever I'm done, I need to make sure that I end this environment. So I will end my enumerate environment. And now once again, I will just Control Shift F5 to compile this. And you see I have my numbering system now. It is labeled the first thing as 1, the second thing as 2. If I were to add something in the middle, it would automatically do this renumbering. So I don't have to think of the numbers as I go. The LaTeX is going to keep track of that for me. So this is one example of a common environment. Now another environment that's very common is, of course, the mathematical environment. So if I want to enter in specific math symbols and math notation, I want to go into a math environment. And there's a couple ways I can get into that math environment. The first way is if I am in the middle of something, in the middle of a line or in some other environment, if I hit the $sign, that will start my math environment, and another $sign will close it. And anywhere in between, I can put my mathematical content. So first I'm going to type in some text so we can see what that looks like. And after that, I'm going to hit some mathematical symbols. So I might say f of x equals 2x minus 4, for instance. Now I'm going to compile that, and we can see what we get here. And so a couple things. One, the sum text doesn't look very good because this is not a text entry environment. This is a math environment. But I can see my function f of x equals 2x minus 4. That does look nice. It looks much nicer than it would in a standard Notepad environment. So that looks not very nice. This looks much, much better. So that's what this math environment is for. So I will get rid of this sum text. There's also certain commands that are built to be in this environment. So for instance, in this environment, I could use the command int, and this will give me the integral symbol. So if I want to integrate my function with respect to x, and then I could compile that. And now you can see that I have my integral symbol. So I can use other math notation inside of this math environment. That's one way to do a math environment. The other way is to begin it, is to do a display math version. I will start my display math environment with those two symbols, backslash and then that square bracket, and I will end it with the other square bracket. And anything that goes in here will be my math environment. So now if I hit f of x equals 2x minus 4y, for instance, f of x, y apparently. Now this environment is similar but different. I am entering my math content, but now it's displayed. It has centered this as an equation to display. So this is the display math environment. And of course, the real power of LaTeX is that almost every conceivable symbol that we use in Mathematica, we can get typesetted in LaTeX. So for instance, I could type in alpha or infinity and get each one of these symbols. And of course, there's countless others. Now, depending on what software you're using, they might have shortcuts built in so you can see these. Otherwise, you can Google to find most of these symbols. Another thing that LaTeX does very well is handles superscripts and subscripts. So for instance, I could type in x squared minus x sub naught. So I'm hoping that will be. When I compile that, we can see it's handled those very nicely. A couple other quick examples of content we will use often. We often like to put in fractions, so that is the command frac. And then I have two sets of curly brackets, one for the numerator, one for the denominator. So I might do x squared in the numerator and x minus 4 in the denominator. When I compile that, once again, there is my fraction. And of course, there are many, many other commands that we're going to learn how to play with. So how do you get started creating your own documents? Well, to get started, if you're running a Linux operating system, then most likely LaTeX is already installed, and you can just access it from the command prompt like you already have, like we've already seen. If you're on a Windows machine, you should Google it. So if I Google downloading LaTeX, this first option is obtaining LaTeX. If I select that, it brings me to this page. Here I can scroll down and see the different distributions. So this is the Windows distribution. This MikTeX is the one that I personally use. It's going to have not only Tech, but also the LaTeX on top of that. And oftentimes it will come with one of those software packages. And then you can either use that or choose to find something else. For instance, when I installed mine, it came with TeXworks, which just is a different software that helps you create documents. I later then switched to Technicenter just as personal preference. So when I selected this one to download, it brought me to this page where I selected download, and this was the downloader that I installed. So I would download this, follow the instructions, and then you should be all set if you're using Windows. Now once you've installed LaTeX, of course, you know how to start off creating documents just using that basic preamble and then the main body. But the first thing you want to do is find out a lot more commands to be more versatile as you create quizzes and exams. So one thing you can do is search for LaTeX cheat sheets, where you can get a list of all the commands. One of my personal favorites is the second one right here. When I select that, I'm brought to this cheat sheet. As you can see, it's just a two-page printout that gives you the shortcuts for lots and lots of commonly used commands. So this is a nice place to get started and play around. And as with anything, the more you play, the better you'll get. And that concludes this introduction to LaTeX.